The last thing I'd like to discuss is the problem of updating an index. In some collections are pretty static. So actually, once you build an index, you don't touch it anymore. Some other collections, for example, web, is very dynamic. So you have to rebuild index every second if you want. So of course, you don't have resources for that, but you have to keep track of new documents, of deleted documents, of updated documents. And so how do you do that? In this course, of course, we will mainly work with not mainly, we will work with static indexes. But in reality, indices will need to be updated. That's why I think it's important to discuss that. So there are a few standard techniques. You can refer to this very, very nice survey by Barla Kambatzoglu and Ricardo Baeza-Yates, who was actually head of Yahoo research for about 20 years. So these guys really know what they're talking about. So there are a few standard techniques to update an index. So what do? You have a memory and you build a delta index in memory. So whenever you see some changes in your collection, new documents or deleted documents, new documents mainly, you add them to delta index. When when you're out of memory, you just flush it to the disk. So you have old main index and a number of delta indices built on the way. And then at a query time, you query all these indices at the same time. You get results from all of them, and then you merge the results. Now, clearly, it's very fast in terms of updating an index, so low index maintenance cost, because you don't bother, you just create new delta index, output it, and so on. But of course, it's high query processing cost because you need to query all of them, and then you will have to merge. And for just-in-time systems, this may not work well. Another approach is an incremental update where you create an old index with some kind of free buffer space. So you think that the index will grow, so you allow some buffer, and then it's super easy, right? You add your new documents to the old index. But there are two problems. First of all, at some point, you will just run out of the free buffer space and you will need some other approaches. And the second problem is that the index update and the index querying are done on the same index at the same time. So there is a concurrency in accessing the index from querying, which is very important to users, and from updates. And that may not work well, again, in systems with a lot of throughput. Now, yet another approach is that you build a delta index, you have an old main index, and at some point you merge them, and we discussed merging techniques. You always query this index, then you put this index into this place, you create a new delta index, you merge again. But imagine you have an index of the entire web, and then merging takes a lot of time because you need the whole web to be merged with very small delta index and so on and so forth. So good and bad for every strategy. But in reality, of course, something in between is used. So some trade-off thing where you do have delta indices and you do query all of them, but delta indices on the way they're merged into larger delta indices. So you do have more than one index. You have this and those, but not as many as just first generation delta indices, so fewer. Second, there's no concurrency. You create those separately, then you merge them separately. As long as they are merged, they appear here. So there's no concurrency, relatively low query cost. So this is a practical solution if you'd like to use one. And of course, pages are not only added or updated, they are also deleted. What can you do with that? Well, the simplest approach is that you kind of maintain a list of deleted documents and you remove them from your results. So after you process your query and you get the ranking, you just drop the documents that have been deleted, actually. And at some point, you really need to run the garbage collection, meaning you have to rebuild your index. So basically, you revert back to one of the techniques where you take the whole huge index and you rebuild it, but that you have to do anyway if you have lots of deletions. So talking about updating an index, there are 4 different updating strategies, and you have to take care about page deletions. And in summary, in general, we've discussed how data is stored, and we said that an inverted index is just one of the structures that contains information only about term document pairs. All the information about documents goes into page attribute files, and all information about terms goes into dictionary. So we discussed what inverted index may contain: term frequencies, positions, document identifiers, weights. We discussed how to construct an index both without too much random access memory and efficiently, like parallel, and how to update an index when you have new pages added or documents or other documents deleted. And the basic material you can read in standard textbooks, and I really recommend this survey here, as I said before. This has a lot of things on crawling, on indexing, and on query processing directly on indices, but that we will touch in. So next set of videos will be from last year, pre-recorded by Evangelos on evaluation. So next week, you'll have videos on evaluation from last year, and in a week, we'll talk about document representation and ranking, and there we will discuss query processing.